All right, welcome Marine Science 20, Introduction to Oceanography students. I'm Professor Kalen Morris, and this week's lab is going to be all about rock and mineral identification, Introduction to Mineralogy and Petrology. Now, after today's lab, you're not going to be tested on this idea, this rock and mineral identification process again directly, but we are going to be seeing in today's lab a couple of rocks and minerals that are of extreme importance in geology and oceanography. For example, we're going to be seeing the granite and basalt that make up our continental and oceanic crust, and we're also going to be seeing the mineral calcite in its form in limestone. That's CaCO3, calcium carbonate, one of our very most important chemicals that we have in the entire planet. So, the big main aim of today's lab is to introduce you guys to the basic properties of rocks and minerals, how scientists are able to then classify them and give them names, identify them based on those physical properties. Now, I hope that if you learn the basic process of it today, that at some point in the future, you're out at the beach or on a nature walk with friends and family, you can help hopefully identify some of these common rocks and minerals that you might encounter in real life. Not that you're necessarily going to memorize all of these properties, but if you know the process, it'd be very easy on your phone to look up the properties in a couple of seconds and figure out the names and amaze all of your friends and family. So, for today's lab, what you're going to need to do is download or print out our handout. It's got some basic information about minerals, and then igneous rocks, and then sedimentary rocks, the types we're going to do today, as well as ways that we can identify them, charts showing their basic properties that we're going to learn about today. If you want, you can print this out. You don't need to. You're not going to need to make any marks on it or turn it in. What I'm going to do is introduce you guys to the basic properties. I'm going to take our samples and show them to you one by one, and when I show you the sample, you're going to go to the quiz that is in the Rock and Mineral Lab folder or module, and you're going to, number 1 and then number 2, so on and so forth, and answer the multiple choice question saying which sample I have shown you guys. So I'll go through the test, tell you what all the properties are. You can say pause the video and then answer that question, and then go on to the next one. All right? So, in our handout, our first page is talking about minerals, where we're going to begin. They're the basic building blocks of rocks, and we do find them plenty on their own, such as beach sand, as we're going to learn. But basically, rocks are made up of accumulations, conglomerates of different minerals. A couple things that we're going to use to identify minerals. Color. Certainly light versus dark, as we'll see in a moment, is very important, but also just whatever color the mineral is going to be listed in its physical properties and helpful in its identification. Now, next big test, hardness. This is literally how hard or soft the mineral is, and we have a hardness scale that goes from 1 to 10. 1 being the softest, 10 being the hardest. And these 10 minerals listed here are the minerals that geologists use that have exactly that hardness. And we have for you guys a little hardness kit, a useful geology kit. We've got numbers 1 through 7. So mineral number 1, talc. Number 2 is going to be gypsum, calcite, so on and so forth. And a hardness is literally how hard or how soft our mineral is. And the way we can figure out which is harder or which is softer is we scratch them. We do a little scratch test. So for example, I've got mineral number 2, gypsum, in one hand, and mineral number 7, that's going to be quartz, in the other hand. Now I'm going to take mineral number 7, quartz, and I'm going to try and make a scratch on mineral number 2. And lo and behold, yes, number 7 was able to make a scratch on number 2 because 7 is harder than 2. If I do it the opposite way, if I try and take number 2 and make a scratch on number 7, it's not going to have any scratch on it because 2 is softer than 7, therefore it will not leave a scratch. So that's a great way to determine a mineral's hardness. Now notice over on the other side of the table, we've got a couple common everyday items and their hardness, where it would fall on the scale. Your fingernail, you've obviously always got pennies are there, knife or metal blade, might be camping with. But most useful for us for geologists is the glass. So we have a glass plate, and glass has a hardness of 5.5, right about in the middle of the scale, and it's very easy to see scratches on. So I can take my mineral, let's say I'll take number 3 here, calcite. That's going to be softer than glass, so it should not leave a scratch. And indeed, it does not scratch the glass plate. If I take, say, mineral number 6, which is harder than glass, okay, that is our feldspar, yes, I can indeed easily scratch the glass plate. And oftentimes, all you'll need to know for a mineral's hardness is whether it is harder or softer than glass, whether or not it leaves a scratch on the plate. After you do that, if you need a more exact idea of the mineral's hardness, you would then use your little mineral kit, your little mineral hardness kit, taking the individual samples. So that's going to be our hardness. We also next here listed have streak. Streak is literally what color the mineral leaves behind in powdered form on a streak plate. For example, if I take number 1, you might not be able to see it too well, but it leaves a faint white streak on the streak plate. Other minerals don't leave any streak at all, and we simply say that they have no streak, so that's another useful test. Another very common mineral property used in identification is what's referred to as the mineral's cleavage. This is simply how does a mineral preferentially break. Because of their crystalline structure, many minerals will break preferentially into these shapes, such as cubic. We'll see that with halite, rhombohedral, we're going to see prismatic, we're going to see, and basal as well. Basal literally means 180-degree cleavage angle where the mineral peels into the thin sheets. And then finally listed, we've got some other physical properties such as color, luster, if it's magnetic, some of them you can taste, and importantly, it will react in acid, causing fizzing to give off carbon dioxide if you have calcium carbonate present. That's CaCO3. So now on to the quiz. I am going to ask you guys, you can have that open, do one question at a time. We're going to start out top of page 2 with our dark colored mineral identification chart. And I am going to grab our first sample. This one we've actually got 2 of, so it'll be relatively easy. This mineral, here's a little pure form of it, a small crystal. It's more commonly found as small little crystals in rocks, such as this guy right here. Okay, it's got a purplish, kind of brownish, dark color to it. 12-sided crystal in its pure form. Definitely harder than glass. Does not have any streak at all. And this guy does not have any cleavage either. So if I look at my table, harder than glass, no streak, no cleavage, dark red-brown color, 2 samples, this is going to be garnet. So I told you guys the answer to the first one. The other ones are going to be the rest of these dark-colored mineral samples. So you can pause and answer real quick. I'm going to go get the second sample now. So now, question number 2, or second question. Here is our next mineral sample. I'm going to check and see. It is maybe just a tiny bit close to the hardness of glass, maybe just a tiny, tiny bit less. Let's see if it has a streak to it. Yes, we've got a, sorry, for a second got myself confused. We have a pale black streak, okay, that this guy is leaving behind. And let's see, we've got a black, kind of darkish gray, definitely metallic-y looking. And we can also test for magnetism. And this guy is definitely magnetic. So go ahead for question number 2. answer that question. Pause, I'll go get the next sample. All right, here is sample number 3. Let's check it out in the glass. It's not quite scratching the glass. Let's try sample number 5. Let's see if it scratches number 5. Yeah, it does scratch number 5, so it's like 5 to 5.5 for its hardness. Okay, let's check if it has a streak. And yes, this guy has a nice, see if you can see it there, there we go. Nice kind of dark reddish brown streak to it. It does not have any cleavage, and this guy is, it's kind of in between a shiny metallic and an earthy dull reddish brick color. So go ahead for that third one, answer the question. All right, for sample number 4 of our dark colored minerals, let's check and see. It's definitely softer than glass, so that's going to be one of our very softest, darker minerals. Let's see, for a streak, maybe a little bit of a, let's see if we can, yeah, a little bit of kind of a pale, kind of a light brown streak to it. And very importantly, this guy has our basal cleavage. I don't know how you can see it, but it's literally peeling into thin sheets here. This guy's actually pretty well cemented. But it's almost like sheets of paper. And they could peel off little bit by little bit. That's how it's preferentially breaking. So that's going to be its cleavage. It's got a black color. It's peeling into thin sheets. So go ahead and answer. Here's some thin sheets peeling up here nicely for you. There we go. There's a little better thin sheets. Okay, and now mineral number 5, question number 5. Let's check our glass plate. We are definitely harder than glass. Let's see about our streak. Not much. Maybe, well, maybe a faint black streak to it. Maybe just a little tiny black streak to it. Now, as for the cleavage, this guy, let's see how well you can see it on the video. This guy has all kinds of little small cleavage angles here. And one of the ways in real life you can look better is with what we call a hand lens, a little 10-power magnifying glass. We'll hold it up to our eye and we can inspect, get a better idea. And this guy has all kinds of little sharp angles that are called cleavage planes where it breaks. They're not right angles though, they're at an oblique angle, so probably like 150, 120, 125 degrees, and then whatever that is to 180. So we have that prismatic cleavage at not a 90-degree angle, not close to it. Definitely a dark black color. It's got these long, thin, shiny cleavage columns. So go ahead and write down correct, mark the correct answer for that guy. Mineral number 6. Let's go ahead with our tests. Definitely harder than glass. As for our streak test, not really seeing any streak. Maybe a tiny bit of, not really any streak, so we'll say none. But like our last sample, this guy has the prismatic cleavage. This guy has the columns, and you can see there are a couple of them here. This is a nice one here. They're very close to 90 degrees. Not quite perfect, but very close to 90-degree prismatic cleavage. It's definitely a dark color, but it has quite a bit of the greenish coloration to it. So go ahead and answer this one, our last dark mineral. Now our next group is going to be the light colored minerals. So that's this table down here at the bottom of page 2. We're going to do the same thing here. Our first sample, make it nice and easy, is the one that has 2 of them. It's olivine. Here's an actual sample of a whole bunch of olivine together. And here you can see the nice green olivine crystals on this guy. Now we're going to do basically the same tests, or almost the same. So harder than glass, definitely scratches our glass. It does not have any cleavage. These are all little tiny crystals of it that we see here. And I can pretty much see through them. It's kind of translucent or transparent where they're small enough. I can see just a little bit of light coming through them, and then that distinctive greenish color. Okay, so this is going to be our olivine sample. So that was number 7, the first of the light-colored minerals. Go ahead and mark that one down. Okay, our next mineral. Let's go ahead and go through our test. First of all, our hardness. That is softer than glass. Let's take number 3 even. See if I can scratch it with number 3. Yep, I can scratch it with number 3, so I know it's actually softer than 3, so it has a hardness of less than 3. And it's not perfect, but what I want you to see here is this guy is basically a cube. It's got cubic cleavage. So this was broken off from a larger chunk of mineral, and it preferentially broke in its perfect 90-degree cubic shape. Ours isn't a perfect sample, or it'd be much more expensive. So we have cubic cleavage. It's transparent. We can see through it, maybe a little bit of whitish color. And now that I've been handling it, I can take my fingers and, oh, that's salty. Tastes just like the salt. So that means it's made of sodium chloride, NaCl. So go ahead and mark your answer for that guy. All right, let's check our next light-colored mineral. First of all, glass. It does not leave a streak, so it is going to be softer than glass. Now I can definitely see some cleavage planes happening here. Maybe can't quite tell the exact shape, but it's going to give me a good hint that the mineral does have some type of cleavage. It's a little bit transparent, maybe a little bit of a whitish color, and I'm going to take a little bit of dilute hydrochloric acid. I'm going to put it on it, and I don't know if you guys can see very well, but this is fizzing, this is bubbling, and you can maybe see the little fumes being given off. That is going to be carbon dioxide gas, telling me that this mineral has calcium carbonate, CaCO3, and therefore it effervesces, it fizzes with that dilute hydrochloric acid on it. Okay, our next mineral sample, we're going to do our glass scratch test. Does not scratch glass. In fact, let me try my fingernail. Yes, I can actually scratch this one with my fingernail. Remember, fingernail is 2.5, so this has to be softer than 2. I have a hardness less than 2. Sorry, 2.5 has a hardness less than 2.5. And if you look here, it has the thin sheet property. This one's kind of tough. Can't quite peel it into thin sheets, but that's how it, here we go. That's how it oh, nice one. How it preferentially breaks into these thin little sheets. That's our basal or 180-degree cleavage. This guy might have some other cleavage planes in here. They're a little tougher to see, but that good basal cleavage. It's definitely transparent. You can see through it, maybe again a little bit of whitish color, but this one can be scratched with my fingernail, and this one does not fizz. No fizzing, so that tells me it does not contain calcium carbonate. Next light-colored mineral sample. Let's go ahead and check the glass. Oh, yeah, definitely is going to scratch our glass. So this guy is going to be harder than glass. And it's tough to see, but it does not have any smooth, flat planes that would tell me it has cleavage. Instead, these are all rounded and curved and random and haphazard. And in fact, some minerals, like this one, do not have any cleavage whatsoever. And that's actually a defining property for them. So harder than glass, no cleavage. Can kind of see through it, so it's transparent, kind of clearish, maybe a little whitish color to it as well. So go ahead and mark your answer for this mineral. Next light colored mineral, this guy right here. We'll start, of course, with the hardness test. Yes, this guy does, in fact, scratch the glass. Let's try mineral number 7. Let's see if I can scratch it with 7. Yep, I can make a scratch on it with number 7. So it's between glass and 7, between 5.5 and 7 in hardness. And if you look, this block is a nice prism, 90-degree cleavage angles. It's very characteristic of this type of mineral. That's how it breaks from a larger chunk. It's kind of pinkish, grayish, orangish, whitish. It's got wavy lines to it, but it's kind of got those earthy, pinky, gray, orangish colors to it. So go ahead and mark your answer. And then our last of the light colored minerals, this guy is going to be definitely softer than glass, and it has our classic basal cleavage, peels into thin sheets, and that's our 180-degree basal cleavage. So little thin sheets of it peeling off. It's got kind of a lightish brown, maybe a yellowish color to it, and a little bit of a shiny luster, and again, that basal cleavage peeling into thin sheets. So that was the last of our light colored minerals. Now for our igneous rocks, that's going to be our next sample on page 3. I need you to pause and first of all go through and read the definitions of the different types of textures, what the rocks look like. Okay? That is going to be one of the things we use to identify igneous rocks, and they are listed here on the left-hand side of the chart. The other thing we use is the color, light to dark, including which minerals make it up if we're able to identify them, and that's what is here in this part. And then the names of the actual igneous rocks are in these boxes down here at the bottom. So I find the texture, I find the color/mineral composition, and then this tells me what the name of that igneous rock is. So make sure you pause, read through this very carefully. When you're ready to begin, I'm going to get out our igneous rock samples. So our first igneous rock sample for you guys to identify in the quiz. This has what we call a glassy texture. So we're in that column. It is dark in color, although of course for the glassy it doesn't really matter. I've once again started you guys off with the easy one. This is obsidian because again of that glassy texture. Now, our next igneous rock type is going to have a frothy or vesicular texture, meaning it's filled with little tiny air holes, little tiny pockets, and those were where gases were escaping while this molten material cooled off very rapidly. And it's going to have quite a dark coloration to it. So if I have a frothy vesicular texture and I have a very dark color that's got a lot of dark colored minerals in it, go ahead and identify this guy. Our next igneous rock is also that frothy vesicular texture. Right? It's got all kinds of, this time even smaller little air holes, but I can really tell because this is a very low density compared to certainly other rocks. But this time it is light in color. It's full of our more lighter colored minerals. So go ahead and identify our frothy vesicular yet light colored igneous rock. Hey, our next igneous sample is going to have a fragmental or pyroclastic texture. It was born out of a volcanic explosion, and there are fragments of other rock, shattered rock and mineral bits scattered throughout this material, throughout this rock. The fragments are relatively small in this one, less than 2 millimeters in size, and it is most certainly light colored, so we have a lot of our light colored minerals. So fragmental or pyroclastic, light colored. Now our next mineral sample is going to be our coarse-grained texture. And that is because I can see all of the individual mineral grains in here with my naked eye. So coarse-grained texture. Now I know at first this guy might look a little kind of darkish, and there is a little bit of biotite. But when I look at the minerals, I see a lot of quartz, and I see a lot of orthoclase. And that's kind of our pinkish, orangish mineral. That was our feldspar. Plagioclase and orthoclase are the two big feldspars. And I see even a little bit of muscovite in here as well. So coarse-grained, it's going to be on the lighter side of the color index because, again, I see a lot of quartz here in this guy, even though at first it might appear a little bit dark. So identify that one. Okay, our next igneous rock sample, we have a fine-grained texture. And it tells us this guy cooled off more rapidly than a coarse-grained texture. So even though it's made up of all kinds of individual mineral grains, they're too small for me to see with the naked eye. So that's our fine-grained texture. And this guy is definitely a dark color. You can also see it's got a little bit even of a greenish hinge to it. And remember, our greens were kind of the augite was the darker green, and the olivine was the lighter green. So we've got a fine grain texture, dark color, a lot of the dark greenish augite in it. Hey, our next sample is also fine-grained because even though I can see some of the mineral grains in here with the naked eye, I can certainly not see all of them, not even close to the majority. So this is going to be fine-grained as well. But this time we are light color. And I can certainly see some quartz in here. And we once again have our kind of pinkish, orangish, grayish orthoclase feldspar quite a bit present. So fine-grained. And then our last igneous rock sample has all kinds of grains of olivine. And even though it is, of course, a little bit lighter in color, because olivine was a light green mineral, this is at the far right-hand side, actually off the scale on the dark side. And I can see all these grains. So this is a coarse-grained rock that has large amounts of the mineral olivine in it. In fact, huge amounts of these little tiny olivine crystals with our coarse grain. Now next, we're going to do our sedimentary rocks. So there's two main types of sedimentary rocks when you read here. The first type, up at the top, are the clastic or detrital, the top half. And these are sedimentary rocks that are made up of small little bits of other rocks or minerals, cemented, compacted together into a new sedimentary rock. And then the second half are the chemical or biochemical. These are going to be sedimentary rocks that were produced by chemical methods, and we're going to talk about quite a bit in class later on how organisms in the ocean actually make shells for themselves out of the dissolved material in the water, and those are going to end up as our chemical sediment, our calcium carbonate. So we're going to start off with the clastic or detrital. Basically, what we're going to look for is how large are the grains that make it up, and then if there's other defining properties. And we're going to start out with this guy. You guys have probably seen stuff of this. Certainly, if you've gone anywhere like in Utah, somewhere like that, you've seen quite a bit of this type of rock. It has sand-sized grains, and I could use my hand lens to really get a good idea of exactly, it looks like sand almost off of a beach there. And it's been cemented, compacted together with our light-colored, basically clear quartz grains. So we have sand-sized grains, cemented with quartz. So go ahead and identify that guy. Our next of the clastic sedimentary rocks is going to have extremely large grains. So you can see this big guy here is a great example, and there's lots of other ones in here. So we're going to have gravel-sized grains, very large, and they're not very sorted very well. And these guys are pretty rounded. You can see nicely this rounding here of these very largest grains. So very large gravel-sized grains, well-rounded. Here, our next sedimentary rock, another clastic, also has very large, so over 2 millimeters, so gravel-sized grains, not very well sorted. But these guys are quite fragmental. So they have quite sharp edges, certainly compared to our last one. So large grains, but these guys are, again, angular, and they're all cemented together into our clastic rock. And then another clastic rock, this guy is going to have very small grains. So small, I certainly cannot see them with the naked eye, and even with the hand lens, I'm not really going to be able to make out individual actual grains of sediment. So very small, very little bitty types of like mud. And the other distinctive property is it looks like it's kind of in thin sheets, yep, and it kind of splits easily. That's what we call fissile. So we've got very small grains, maybe bits of mud, clay, silt, cemented together into these thin fissile sheets. And next we've got our chemical sedimentary rocks, ones made by chemical methods. And as I mentioned, we're going to learn all about in class how organisms take the dissolved minerals, the dissolved materials in the ocean water, and use it to build shells for themselves, quite often out of calcium carbonate, CaCO3. They die, fall to the bottom, and their fossils get compressed together into new rock. So here you can nicely see a shell fossil here. And I can test that this is made of calcium carbonate, CaCO3, because it's going to fizz, effervesce like crazy. Okay, so this guy is a well-cemented, fairly dense rock. I've got some obvious fossils present, and it's calcium carbonate, CaCO3, so it fizzes, it effervesces. Now here we've also got a fairly dense, well-cemented rock. This time there's no obvious fossils, and that's fine because actually the vast majority of organisms in the ocean making these shells are microscopic, but there's huge, huge amounts of them, and when they die, they fall to the bottom, get compressed into this new type of sedimentary rock made of calcium carbonate. But it looks like a kind of crystalline rock instead of the obvious fossils found. But it's made of calcium carbonate, effervesces, fizzes with CaCO3. Next chemical rock, chert. This is actually one that is made by entirely chemical, not biological processes. Let's actually check this guy on the glass. And yes, it is quite hard, scratches glass, and it has these distinctive, smooth, curved surfaces. They're what we call conchoidal fracture, and it looks like I can't see the individual crystals, but a whole bunch of little tiny crystals together. Scratches glass, smooth, curved surfaces. Now for the last two sedimentary rocks, I'm going to present them together. They basically look identical, chalk and diamatite. Okay? First we're going to do the chalk. Now chalk, if you read there, is made of calcium carbonate, CaCO3. So it will effervesce, it will fizz with my dilute hydrochloric acid, and it fizzes massively, unbelievably large, because these are tiny, tiny, tiny little microscopic shells made of calcium carbonate all pressed together. Now diamatite is the same thing, little tiny shells, but they're not made of calcium carbonate. They're made of silicate, which does not fizz, does not give off bubbles. So this guy, there might be a tiny bit of fizzing because chalk just gets everywhere, but I want you to see here, it has a little fizzing, but nothing compared to our chalk, obviously. So the first one we're doing, 29 is the fizzing, and then the second one without the fizzing, the diamantite. So that's what you guys needed to do for today's lab. Finish up that quiz, go back, look over it, pause in between if you need to, and hopefully you guys will be able to someday impress your friends and family with your newfound rock and mineral identification skills.